Today we're in section 4.1. We're working through factors and prime factorization of numbers. The first thing we need to write down are some terms. Okay, so here we have terms. Three terms you need to know: prime number, composite number, and a factor. Okay, let's talk about factor first. A factor is a number that can be multiplied by another number to equal some number. What does that mean? It means that it can go evenly into some number. So let's talk about 10. The number 10. Well, what numbers can evenly go into 10? 2, 5, 1, and 10. Those numbers are factors of the number 10 because they're evenly divisible. All right, now a prime number is a number whose only factors are 1 and the number itself. Composite numbers have other factors. Honestly, you could just write that for your definition. Composite numbers have other factors other than 1 and the number itself. And which number is not prime or composite? The number 1. The number 1 is neither prime nor composite. It's just neither. All right, take a minute and write these down. It says your school yearbook will have 24 photos in a rectangular display. If you want no more than 10 photos in a row or column, how many ways can you arrange them? So we've got to figure out, okay, obviously we can't have any leftover numbers, so what combinations of numbers would fit this criteria? Well, we can do that by starting to list the factors. 1 times 24, 2 times 12. What's some other factors? They can be multiplied together.
4 times 6.
Very good. And 4 times 6. All right. Well, which two of those are ruled out because they're more than 10? The first two, right? 1 and 24 and 2 and 12, because I only want, okay, I don't know what that was. I only want 10 photos in a row or column. I don't want it to be like 2 rows and then 12 down. It's not going to fit on the page. All right, so I can have 3 rows of 8. I could have 4 rows of 6. Could I flip it? Could I have 8 rows of 3 and 6 rows of 4? Would that be different? Yes. So 4 displays. Possible. You see how we did that? We figured out the factors and we could arrange them in different orders to get those different numbers. All right, so it's going to be 4 displays. I believe number 46 is like this one on your homework. So number 46. So that should help you on that one. Now on example 2, we're going to start, well, let me see. Hold on. Sorry. All right, so that's example 1. Now let's talk about and you don't have to write these down. These are just some examples of prime and composite numbers. I just want to show you this, okay? So what it means to be composite is that it has other factors other than 1 in the number itself. You see, for 24, there's a lot of factors. That's why it's composite. For 41, however, there's only 1 in 41. A number is always going to have a factor, but it might only be 1 in the number itself, so that's why it's prime. 51 is commonly thought of as prime, but it's not. It's composite because 3 and 17 are factors. 89 is prime, and even though 121 only has 1 other factor, it's still composite because the rule for composite is it just has to have at least 1 other factor. So let's talk a minute about these generalizations about prime and composite numbers. True or false? All even numbers are composite. All even numbers are composite. True or false?
False.
Why is it true? Because what's always going to be a factor? 2. If it's an even number, but it's a factor. I'm not talking about prime factors. 2 is a factor. The rule for composite is as long as it has at least 1 other factor, It's composite. So even numbers will always have 2 as a factor, so it's composite. All even numbers are composite. True or false? All odd numbers are prime.
False.
Why?
Because 51 is odd.
Okay, look at some of these examples on the screen. 51 is composite. 121 is composite. 9 is composite. 15 is composite. We could go on and on. So that is not true. Okay, however, the prime numbers, let's start listing them. Let's list all the prime numbers under 30. What's our first prime number? 2, 3, 5, 7, 11. Say it with me. 13, 17, 19, 23, 29. Okay, and then 31, and it just keeps going. All right, now 27, because 9 and 3 are factors. Okay. All right, so now let's move on to... Why isn't it moving? All right, so for 30, okay, so we're doing the listing the factors and telling whether the number is prime or composite. So for 30, I know that other 2 numbers changed. Just bear with me for a second. We listed out our factors. Did you list out those numbers? And it is composite. It is composite. Now, for the other 2 numbers, let me switch slides real quick. For 31, 1 and 31 are the only factors, so it's prime. All right, so you have some questions like this on your homework assignment, and that's how you're going to do them. Now, in example 2, we're going to do what's called the prime factorization of the numbers. Now, here's what it means, okay? I want you to think of a number like a puzzle, okay? So here's your number, 27, okay? This number is your puzzle all put together. That's a whole number. What I want to do is, within that puzzle, there's pieces that put it together. Those are what we call the prime factors. The prime factors together, multiplied together, will equal that number. So there's 2 ways that you can find the prime factorization. The first way is through factor trees. What are 2 numbers that can be multiplied together to get 27? 9 and 3. And I keep factoring until all I have are prime factors. Then I write my repeated prime factors as powers, 3 to the 3rd power. That's how I do prime factorization. So that's pretty easy. There's another way I can do it, though, and some of you may have learned this last year. It's called upside down division, where here's my rule, and this is definitely the one that I prefer. I must divide by a prime number. So divide by 3, 9, 3, and 3. And as soon as I have a prime number on the bottom, I know that I've finished the prime factorization, and guess what? It's the same exact thing. But here's why I prefer upside down division. If you don't have that all the way written down, that's not a big deal. But here's why I prefer it. 630. Raise your hand if you want to do a factor tree on that number. Okay, that's not fun. And here's why. Because for 630, guys, well, what if we did, say, 63 and 10? Technically, you could. All right, and then you just break it down, break it down, break it down. It's just with a factor tree, you're opening yourself up to making more mistake. And honestly, it takes more brain power to do a factor tree than it does upside down division. Because with upside down division, it's just, I just divide by a prime number. What if it's an even number, what's a prime number that goes into it? 2. So if it's an even number, start with a 2. Divide by 2. 315. Okay, now that's an odd number, so what's a number? I could go 3. 105. Then I could go, I can't do 6. Why can't I do 6? It's composite. It's not prime. You could do 3 again. Or, so L'Ariel just said, I could do 5. So, listen. Your upside down division does not have to be in the order that I'm doing it. As long as you're dividing by prime numbers, you will still get the same answer. It just might be in a different order. So we keep dividing by prime numbers until we have a prime number on the bottom and we know we're done. Now, in your prime factorization, you need to list your prime factors least to greatest. This is important, and it makes it much, much easier for me to grade if they're listed least to greatest. So remember to write your repeated factors as powers, and you've done the prime factorization. We're going to do 550 now. Okay, 550. I want you to do the prime factorization of 550. Guys, so let's check. Okay, so 550, we were supposed to do prime factorization. All right, so I started by dividing by 2. All right, then 5, then another 5 and 11. So 2 times 5 squared times 11. All right, did you get that right?
Yeah.
Okay, very good. All right, now in example 3, we're going to skip the checkpoint for now. Let's jump over to monomials. I need my slide that talks about monomials. There it is. Factoring monomials. All right, you need to know what a monomial is. It's a number of variable or the product of a number and one or more variables. So did it say the sum or the difference? No, it said the product. So it has to be multiplication. It cannot be addition, subtraction, or division. It's got to be multiplication in order to count as a monomial. So when I factor it, I'm going to write the monomial as a product of the prime numbers. What does that mean? It means do the prime factorization. And the variables with exponents of 1. What does that mean? That I break down. So if it's n to the second power, okay, let me change my color right here. If it's n to the second power, that means n times what? N. If it's y to the third power, how many times am I multiplying y? 3. Y times y times y. So I'm just breaking it down and multiplying it however many times the exponent value is. Okay, so here's what we do. We're going to break this down, okay? Do you agree that it's 28 times x times y to the third, that I'm multiplying each part of that term together? So here's what I'm doing. 28, I need to do the prime factorization. And then I've got times x, well, that's by itself, times y to the third, so I need to break down y to the third. So I'm just breaking down each part of the monomial into its individual pieces. All right, so 28, I do upside down division, and then I've got x times y times y times y, and now I just write it all together. And they even want us to go as far as breaking down everything. So I don't write anything as a power. I'm going to break it down everything. 2 times 2 times 7 times x times y times y times y. How did I know y 3 times? Because up here in my monomial, it was y to the third power. If it was y to the fifth power, I would multiply y 5 times.
Hey, teachers.
Okay, so now I want you to do, this is the last one, I want you to do the, I want you to factor this monomial, 18sp to the fourth. Go ahead and factor it, break it down into all of its prime factors. Okay, so when I factor 18, I do the prime factorization, okay, and then, hey, stop talking, that's enough. Okay, then I multiply times s times p, how many times?
4.
4 times. Okay, and that's how I'm going to do it. Numbers 48 through 55 are just like this on your homework tonight. If you understand that, that's everything you need to know for 4.1.